Okay, so how is everyone today?
Good.
Good? All right. So we've been to the lab now. That's good. We got to use MATLAB, at least once. So to sort of recap what it was that we did in there. Today's the 30th. Is that in this class we basically use 3 programs. One of them is that we use GitHub, and this is through the web browser. You know, whichever web browser is your preference. So we use GitHub through a web browser, and the purpose of GitHub, using it from the web browser, is the following: is that I make programming exercises for y'all, and the description of what it is that you're supposed to do is on those web pages. Okay, so these describe. So as far as purpose is concerned, this is where we describe the various programming exercises. Okay, so at the present time, there are 3 programming exercises posted. One of them is named 000, one of them is named 001, and the last one is named LIB for library. So 000 and 001 are, in some sense, basically just like welcome to GitHub. And if you haven't done it yet, well, I'll say this. For those that have done it, because many people have done it, would you agree that 000 and 001 are pretty straightforward? Yeah, right. They're really easy. So they basically just can you log into the web browser and follow some written instructions. And you definitely could do it in an hour, but more likely like maybe 30 seconds. Okay, so fine. And then there's also, besides those 2, which require no programming whatsoever, there's LIB, which does actually require some programming. Okay, so between the time of the lab and now, I've graded your GitHub stuff a couple times. Okay, now I also sent a message, and so I'm going to say it again just in case some of y'all's hearts just sank. Okay, don't panic. Okay, I understand that you might not have finished all those programs. Okay. So the way, one thing about that is that the way the programming assignments are going to work is that if there's something wrong with your programs, for example, if those files just don't even exist, which might have been the case for many of you, then an issue is posted to GitHub. So this is another purpose of GitHub from the web browser, is to deal with issues. You can kind of think of this conceptually, it's kind of like a to-do list. So you might have received, like all of a sudden, like 15 emails from me. Well, not really from me, I guess, but from GitHub. But I was, I had something to do with it. And they're saying, basically that your programs aren't right, and this is what's wrong. So you need to have a look at it and fix it. Well, that's the way it works. So the basic process is that I post some programming exercises for you, and I'll say they're posted, and sometime after they're posted I begin grading them. So I grade it, and if there's something not right, about it, then a message on GitHub is created. You receive an email, and you know, the issue describes just what is not okay, including, you know, the file doesn't even exist. So you get those messages, and then you read the issues. You figure out, you know, you try and figure out, you know, what is wrong, and then you make some edits, and you push those changes to the repo, and then the next time I grade your stuff, I'll get those changes and then grade it again. And the purpose of this is to make a feedback cycle where you do something, I respond, and by saying, you know, here is the manner in which it's not correct. Okay, then you make fixes. And then I grade again and respond. And we go back and forth until it's right. Okay, so that's the cycle. In principle, okay, I don't care how many times we have to do this. You know, for some of you, if you have previous programming experience, you know, maybe you got one or all of them right already, and even on the first try. Wow. But you know, most people aren't going to be in that case. So in principle, I don't care how many times it takes. However, that has to be governed by, you know, like reasonableness. Okay, so I don't care how many times it takes, as long as it seems clear to me that you're making progress. Okay, but if you're like abusing the system, or you know, if you wait like 8 weeks and then suddenly expect me to grade it, that's not going to happen. Okay. So as long as you're making regular progress and it looks like you're doing something, then I don't care how many times it takes. I don't care how long it takes. I mean, we can't go beyond the end of the semester. Okay? Now, that being said, there's no due dates yet. Now, the reason why there's no due dates yet is because of the following. So y'all haven't quite figured it out yet, but I'll say this, which may come as a surprise to many of you. There are a handful of students that are already done with all of those things I submitted. Okay, and that's because, in the end, the reason why that has happened is that even though, because y'all are in the same class, y'all at least have some basic similarities. Meaning, and the only one I can count on is that you've all taken pre-calculus. But in fact, some of you have had programming experience before, and you know you're already know how to do a lot of this stuff. Some of y'all are that way. Some of you are doing this for the very first time. That's fine. And so, you know, y'all are all just like a big jumble in here. I don't know who's who yet, and y'all probably don't know who's who yet. So the reason why there's no due dates is because, like, if I was to make a due date like right now, what would happen is that the people all of this stuff is very new, y'all be like in a panic, you know, like cold sweats, you know, and then you know, y'all be like beating down my office door and wouldn't give me any rest. So there's no due dates yet. The due dates are we're going to have at least one more lab before I start setting any due dates. So the purpose of the next lab, which is to say on Tuesday, 5 days from now, is I'm going to show y'all, we're going to do two things. And one of the things is I'm going to show you how do I grade your programming assignments. Because many of y'all's questions throughout the semester can be answered right up front by just showing you. So I'll just literally just show you how I grade. We'll watch the screen and I'll grade a few programming assignments. Okay, and you know, y'all's repos are named, you know, they have those names, 18F-math-2370-Q. Everyone has a Q, and then you've got 4 random hexadecimal digits. So hexadecimal meaning 0 through 9, and also A through F. So when I look at those, you know, I have no idea who. I have no idea whose repo is Q and then 1 to F7. I have no idea. So when I'm grading, part of the purpose is to make sure that when I'm grading, there's you know, no chance of like bias, right? I can't like one way or the other, right? I can't like, you know, be hard on you or be easy on you. The other purpose is so that I can just show it on the screen. right? It wouldn't be permissible for me to like say, you know, here's a you know, Joe's assignment, and now let me just grade it right in front of everyone. Okay, that wouldn't be good. But it's anonymized, so I can just, you know, we can just look at it. Okay. So that's one purpose of NextLab. That'll only take like maybe 10 minutes to get through that. And then y'all are all going to sit down and you know, and get to work, set yourselves to work, and then you just ask questions of me and of each other, and figure out how to get this going with MATLAB. Any questions about that? So no due dates yet. Please don't panic. To remind you, the way the lecture is gonna, the way the semester goes, is that we will lecture on Thursdays and then lab on Tuesdays. And the lectures, what they are, is we're going to go over a math topic, and usually it will be a math topic that you already know. Like, you know, a couple lectures ago we talked about how to multiply 5 and 23 and 2370. So I suspect that you probably could have done that before you got here. But you know, we talked about it in this sort of really overbearingly precise way, describing what it means to multiply by a natural. And the reason is because that's how you communicate with MATLAB, in a like an overbearingly precise way. Okay, so we're going to talk about, you know, we're going to talk about some math topic you already know, but very precisely, and then we're going to go do it in the lab. Okay, so then the issues are like a to-do list, etc. So another program that we use is GitHub Desktop. So GitHub Desktop is not, it's that program that wasn't a web browser. It's that other one, and it wasn't MATLAB. It was the thing where you had to log into it just like you were logging into GitHub, but it wasn't a web page. It was a program. Okay, so the purpose of GitHub Desktop is the following: is that for each one of you, I made a repo, a repository, a place where all of your files are located. This is called the remote repo. And depending on things, it might not be called the remote, it might be called the origin. So parenthetically, I'll just write origin. So what this is that you have files that correspond to you, and they're out on the wild internet somewhere. You know, who knows where they are? They're sitting in some, you know, probably some big room that's full of computers, but I have no idea where it is. It's probably like in California or something. But at any rate, it doesn't matter. So what conceptually what happens is that like 2 days ago in lab, you know, I said, okay, you know, log in, select your repo, and click clone. So what that did is you connected to this computer that's out in the wild internet, and you said, hey, you know, I'd like to have a copy of all those files here. And so that is called a local repo. So you connected and you click clone, and you said, you know, give me all those files there. So you got them. Okay. Then we made a few changes. We made a few changes to the file. We made the file isr, or at least, you know, I was showing how you could in principle do it. So you made a file. Okay. Then you have to do a couple steps. One of the steps is to go back to GitHub Desktop and tell GitHub Desktop that I want this file I just made to be a permanent piece of this repo. So when I said something like, you know, go to the thing and click on changes, and then type a summary of what you did, and it's just for you to help you remember, and then you click do it. Okay, what that did is that that made the changes permanent here. Okay, but here's the thing, is that you know, that might have been a lab computer, that might have been your laptop. It doesn't matter, but I don't have access to the lab computers, to your files on the lab computers, and I don't have access to your files on your laptop either. So in order for me to get access to them, you first say, I want all those changes I just made to be a permanent part of this local repo. And then you have to say, and furthermore, I want to update the remote repo with those changes. So this, there's another arrow going the other way, like that. So conceptually, so the first time that you do this, that you go this way, the very first time, that's called a clone. Now, if you always use a lab computer, it's always going to be cloned, because when you log back into the lab computer, it's like starting from the beginning. But if you have a laptop, you just clone the first time, and the rest of the time is just called a pull or a sync. So pull. Okay, then you make some changes locally. You add them to the local repo, like was described in lab, and then now you've got to get it back over here to the wild internet, and this is called a push. Okay, now if this isn't making entire sense yet, here's the other issue, is that this is you. Okay. Then after we get out of lab, and when I set aside time to do it, I grade your stuff. So I've got my own local repo, but this one's mine. And so what I do is when I'm going to go grade your stuff, I do a pull, and then I grade it. Okay, and then if there's new programming assignments, or if there's other files that are necessary to describe to you what's right and what's wrong about what you've currently written, I also do pushes. So understand what this means is that if you don't do the push, then I'll never see what it was that you did. So here's one way in which this could have gone wrong for you on Tuesday. You could have gone into the lab. You could have made changes to the file isr, as I was doing it and you're doing it. That could have happened. And if you left a classroom and you didn't do this, you didn't push it out to the remote, then when you logged out of the lab computer, it all just evaporated into nothing. It's gone. Okay, because the lab computers, when you log out, they reset, they clean slate, like everything that you did is gone. Now, if you were doing it on your laptop and you forgot to push, it's still there. You could go to your laptop right now and just go click, and then it would be there. Okay, so does everybody understand the idea? Yes.
Can we verify that we have pushed it?
So in the first place, there's a button that says push. So if you click it, then it'll work. But if you're trust but verify, that's a good motto. On the GitHub Desktop application, you can click push or sync or what have you. On different versions of GitHub Desktop, sometimes it's called push and sometimes it's called sync. Then you can go to the web browser and just look. Because if the web browser, you're looking at the remote repo. That's how. Does that answer it? Other questions? Yes?
Approximately how often do you pull files to grade them?
I try to grade several times a week. Because in the first place, if I wait real long, then it's like an enormous task, So I like to make it smallish. Also, just from like a teaching point of view, making the whole idea here is that setting up a feedback loop, where I say you need to do something, and then you do it, and then I give you feedback. I say if it was good, and then it just keeps going. The tighter the loop is, the more rapidly I respond and then you respond, the better that, generally speaking, the better the outcome. Now, that being said, I'll remember, I'm going to explain how I grade on Tuesday. So a lot of questions about like that will be answered and made clear on Tuesday. Other questions? So GitHub Desktop's entire purpose in life is just the management of this. Okay, you can conceptually think of it like a locker, kind of. That we each could walk. We each, each pair of us, each student has their own locker, and you can imagine like you know the combination and I know the combination, and then I put something in the locker for you, and then you've got to go like look at it and write your messages or whatever in it, and then you put it back in the locker, and then I go check. It's like that, except they're files, and somehow you can make copies of the locker. It's not a perfect analogy. Any questions? All right. So the other last program that we use is MATLAB, right? Okay. So that's the thing that we're doing. Any questions about this? Okay. Any questions before we get to math? Now that we've kind of talked about this a little bit. All right. So last time we were talking about how to add. Not add. We were talking about how to multiply. We were talking about that multiplication by a natural is, in fact, repeated addition. So we had defined something like this. So I can say define mult underscore n underscore r from naturals cross reals to reals as mult underscore n underscore r equal to that. Okay, so then now, that's kind of a strange name in a math class to name something mult underscore n underscore r. But because in math classes usually you just name a function like a single letter, like f. But in programming generally, the names of things, usually describe what it is that they do. So now, because the signature of the function says this to that, and because that says naturals cross reals, what that means is that we're talking about a function that has two arguments, a first and a second. So the first one I'll call n because it's a natural, and the second one just x there. And we already wrote this. This is not new. I'm just reminding you of the things that we did. The way to define this function is it's going to be defined in with two clauses, and the first clause tells you what to do with the least natural. So what's the least natural? 0. So in the case that n is 0, remember what we're doing. What we're really doing is defining n multiplied by x without using multiplication. So, but using your previous knowledge about what it's supposed to be, what about when n is 0? What's the answer? 0. Okay. Then for any other natural, which is just to say, otherwise, how do we write the answer? No, we can't write n multiplied by x.
Plus mult underscore n underscore r.
Uh-huh.
N minus 1 and x.
So mult underscore n underscore r. So that means that in order to evaluate mult underscore n underscore r with these arguments, you must first evaluate mult underscore n underscore r. Now, it couldn't possibly be the same arguments because that could not conceivably constitute a valid definition. So what arguments? Right, n minus 1 and x. So you can't use multiply here. I mean, MATLAB has a multiply, but what we're going with here conceptually is that we're defining multiplication. So you can't use multiplication while you're defining it. That can't be made to work. So this this first one conceptually. So numbering them. The reason why this definition works in the end is because the first one is necessary. It's saying that well, 0 multiplied by x, using your previous information about multiplication, well, that's 0, isn't it? Okay. The second one is saying something like, well, for example, suppose you wanted to calculate 5 multiplied by x. What if you wanted to do that? The second clause is saying that, well, isn't it true that that's equal to x plus 4 multiplied by x? Yeah, right. That's what the second clause is saying. But notice that it's saying that without writing multiply, without using the punctuation, without writing the dot. Okay. Good. Any question about this? By the way, why is that 0? And you can't say because I know it. Why is it 0? That's it. What was it? Right. Because what you're asking is that what if we're making a sum? What if we're summing stuff together, adding stuff together, and the number of things that we're adding together is 0. So we're adding together nothing. So which is to say the empty sum. Well, in that case, the empty sum should be the identity element for summation, the identity element for addition, which is 0. That's the reason why. It's not because you knew this. That's a fact. But the reason why this is the case is because 0 is the additive identity. All right. So fine. Just like, so multiplication is repeated addition. But just like that, raising to a natural exponent is repeated what? Repeated multiplication. Okay, so let's do that. So define, in computer science usually it's called POW for power. So POW underscore n underscore r. And I'll give it this signature. But this is in fact not quite right. So if you're writing in pen, you need to give yourself some room to fix it. So I'm going to have to fix it somehow. But for now, I'm going to just leave it like that. So the signature is not quite right. And I'll define it as the following. So POW underscore n underscore r of n and x. And again, conceptually, what we're doing here is we want to define this one, x to exponent n. But again, it's not permitted that that we should use that, which is to say, most of the time in math classes, or at least much of the time, when you mean multiply, you just write the two things side by side and nothing in between them, and then the juxtaposition of those two things is understood to be multiplication. And usually you don't write the dot. However, I've taught for a while now, and I find that students do better when I write the dot, and like their performance is better. And then I find that when the students take up the habit of writing the dot, their performance is even better. So I'm not like saying you need to write the dot, but you might consider it. At any rate, what is the punctuation? Just like the punctuation for this, the symbol is a dot. What's the punctuation for this one? Caret. So in some sense, what we're defining here is we're defining what caret does. But and as we do it, as we're defining it, it's not permitted that you should use caret. You can't use caret while you're defining it. Okay. So just like this one, it will be a function defined with two clauses. And again, just like this one, we'll need to consider a case when n is the least natural. So the least natural is 0. All right, the least natural is 0. So what should the answer be? 1. Wait a minute. I thought that we said that when you're doing that, it's 0. You're telling me that this one right here should be a 1? Very good. So this is a 1 because what we're saying, what this means. Remember what this means. This is saying that in order to do this, you should make n copies of x and multiply them all together. So if that said x caret and then 23, you'd make 23 x's and then multiply them all together. So this is going to be x multiply x multiply x multiply dot 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 multiply x, like that. Okay, and there's 23 of those. And then the question is that well, what about if there's like 0 of them? So when n is 0 here, in this case that's referred to as the empty sum, and the answer should be the identity for summation, which is 0. Here, if n is 0, then it should be the identity for multiplication, which is 1. Good. So otherwise, what? What's the answer? So I heard x, but you're talking very faintly. Okay. Uh-huh. Very good. So for those of you that didn't quite catch that, so before I write the thing, I want you to see that. Do you observe it's like structurally like identical to this one? It's like basically the same. The names are a little bit different. The operation is a little bit different. Instead of plus, it's multiply. But then for these arguments, this should be n minus 1 and then x. Now, to be clear here, so now there's in fact there's 2 errors on the page now. 2 things are wrong. So now we need to talk about what things are wrong, and we need to fix it. In the end, this is good, unless there's something I don't see. But I don't think there's any errors up here. But this one has 2 errors in it currently, and it comes down to the basic underlying fact that multiplication is just it's a slightly more complicated thing than addition, and as a result, some things can go wrong. Things that you just can't go wrong with addition. Okay, so let's try and figure out what's not right about this. So as for the first clause, why this? So I want a reason like that. Okay. So, all right. So I'll just leave that there for a second. And then as for the second clause, why does the second clause take its shape? Maybe a reason like that one. Right. Because, isn't it the case that x to exponent 5 is equal to x multiplied by x to exponent 4. Isn't it the case? Yeah. Okay. Nevertheless, now there's 3 errors on the page. Okay, now wait a second. I have a question. How about what is 0 to exponent 2370? It's 0, right? Ah, okay. So you might he said something and he probably knew what he meant, and then I responded in this difficult, complicated way and said, "What about this one?" But the reason why I'm doing that is not to be difficult. Well, it is to be difficult. It's not. It's nothing personal at any rate. The point is that that's what MATLAB's going to do. MATLAB's just going to do whatever you say. So this is fine. So it's permissible for x to be 0 in principle, but as he said, it's well. And how about this one? Is it permissible for n to be 0? Is that okay? Yeah. So 2370 to exponent 0 is 1. But as he said very nicely, it's not permissible for both of them to be 0. So this is undefined. Now, well, here's the deal: is that as written, this couldn't possibly really be the domain of this function, because this set as written currently includes 0, 0. So now in math language, how do we fix it? A star? Okay, I'm not sure what you mean.
If you were to modify R star or N star,
Okay. So let's write those things down. So remember, so one common notation, like if you've taken, well, just depending on your math experience, but for example, if you've taken abstract algebra, you probably considered something that was denoted R star, like that. And what this is this is the set of all x's such that x is in the reals and x is non-zero. The reason for that, at any rate, is that this set R star constitutes something called a group under multiplication. Okay. So by analogy, n star means the same thing. Yet, for reasons that I won't go into, it's not a group. Whatever that means. Okay, so then the suggestion, I think, is that I should put stars on both of those. Now, would that be correct? It wouldn't be correct. Why is it not okay for me to put stars on both of them? So the question that I'm posing, the first question that I'm posing is that should it be n star cross R star? Right. So this is saying that this one right here is saying that it's okay for n to be 0, as long. It's okay for x to be 0 so long as n isn't. Okay. And this one is saying the other thing. This one is saying it's okay for x to be 0 so long as n isn't. This is not right because to put this in plain language, this is sort of like saying it's not okay for either one of them to be 0. Like just zeros, we just won't have it. They're out. So it's not this one. So no, because it's okay for exactly one of them to be 0. right. So exactly one of n or x. Okay, so what's an, we're like searching. What do we need to do? Yeah?
It needs to be n cross r minus the work there 0, 0.
Okay, good. So, in sets, there's this thing, there's this idea like called, subtraction. That means probably what you think it means. So you can take two sets, A and B, and then calculate A subtract B, and that just means we're talking about all the things that are in A that are also not in B. So you can write it without subtraction by, if you have a universal set, by saying something like it's A intersect B complement. Whatever. So that's called subtraction. So in fact, the answer is this. So n cross r. So that's all of them, and the bad one is 0, 0, the one we want to be rid of. So then you can write it like this: subtract the set containing just the single bad one, 0, 0. So now I'll mention that different mathematicians write this differently. Some I'm an example, write set subtraction just like a normal subtraction. But as it turns out, there's some strong opinions about this, like how you should write it. And so if you look in a different textbook or whatever, then this instead of writing it as a subtraction, it might be written as a reverse solitus, which is a fancy way to say backslash. So like this one. I don't have a really super strong opinion about it. Feel free to do whichever one seems best for you. I use this one just because I don't really see the need to introduce a completely new thing, a completely new symbol. I mean, subtraction is already perfectly serviceable. Okay, so then to make this right, we've got to make that edit. All right, and then now let's also fix this definition. So how can we fix this definition? In some sense, from a math point of view, you don't really even have to fix it because we fixed the signature there. Okay, but nevertheless, I want to sort of point something out. Is that it's going to be this, like that. But what would be the problem if x were also 0? So we can change this to say n equals 0 and x not 0, something like that. But really the main fix is right there. So can we see that there's when you're dealing with math things, that in principle some things are just undefined, like 0 to 0, 0 to exponent 0. All right. So now, yes.
Wouldn't under this definition anything?
Okay. Good.
0 to the power would be undefined because it's recursive and will eventually go to 0 to. Oh, it will eventually go to.
Oh, I thought you had caught me. There's actually one little minor thing here, but but you hadn't. Okay, so what was it?
Wouldn't anything 0 to any power be undefined because it's like recursive, so eventually it would just go down to. Oh wait, no, it goes down to 0 to the 1. Never mind.
Okay.
Never mind.
All right. Other questions? Yes?
So you specified that when n is 0, x can't be 0. Do you have to specify the opposite? When x is 0, n can't be 0?
Yeah, I mean so that's the one that I'm omitting. So there's a slightly different problem. And I'm going to just move past it. But I agree entirely with what you're saying. In the end, The real fix is the fact that we fix the domain, that we have it written right there. In the same kind of way that if we were in a college algebra class, or like a high school class or whatever, and you were learning about square roots for the very first time, you had no idea what a complex number is or anything like that. If I were to say, you know, okay, what's the square root of 36? And then the answer would be 6. Okay, and then someone, you know, some clever student who, like, you know, read ahead in the book or whatever, might say, but, you know, what about -6? And then you say, no, well, I agree that -6 squares to 36, but, you know, the square root of 36 is just 6, for reasons that aren't clear until you get a little later. Y'all are almost to that point where you can say just 6. The reason why, you know, if you want to just know the math magic word, why it's just 6 and not -6, there's a couple reasons. One reason is that functions can only have one output, but really probably maybe a better reason is to say that the square root is the unique semi-definite value, so it's got to be 6. That's because all numbers have 2 square roots, and all complex numbers have 2 square roots, and all complex numbers have 3 cube roots, and all complex numbers have, you know, 47/47th roots. Okay, good. Sorry. So if I asked you, again, continuing that, saying in the college algebra, we're in college algebra and have no idea what a complex number is, if I say, well, what about the square root of -36? Then what's the correct response? I have no idea what complex number is. I just got finished saying that. So complex numbers are not a thing. Right, so this is undefined. There is not a real that will square to -36. There isn't one. So, you know, you can't put negative numbers into the square root. So this concept of things being undefined, okay, this is now what we're talking about. How do you get MATLAB to say something like that? You know, that like, no, I refuse, I won't do that. Okay, so we're going to do something like that. Okay, so here's an example. So now we're going to have like a really contrived idea. So what we're going to do is we're going to define a function. I'll make its name good underscore number, and it'll be a function from the naturals to the set false and true. So that f means it means false, and the t means true. So we're talking about a function that you can plug in a natural, and then out should come false or true, and it's going to have to satisfy the following. Satisfying. So first, if the input is $23 or 70, then the answer should be true, and then otherwise the output should be false. Right? So again, now to remind you, like, this is like a completely contrived example, but the point, remember what the point is, the way the course goes, is we talk about some math idea, things that are completely comprehensible, but we have to talk about them in kind of this really super precise way so that you can translate this to MATLAB, because that's the only way MATLAB's going to do what you want. All right. So, you know, for example, examples of this, you know, continuing the math exercise, you might be, I might ask you, please evaluate good underscore number. Please evaluate that at 8. And please evaluate that at 23. And please evaluate it at how are you supposed to respond to this request? In a math class now. Okay, so how about this one? False. How about this one? True. And then what's the correct response to this one? It's not false. This is undefined. It's not in the domain, right? Because the domain says naturals, okay? So the domain has to be naturals. Is 3.5 natural? It's not. So this is undefined. So now what we're going to do is we're going to write some we're going to write a MATLAB function that does this. And what we want to do is that we want it to be such that when you plug in 8 and other numbers, other naturals that aren't 23 or 70, you get the answer will be false. When you plug in 23 or 70, the answer will be true. And when you plug in something like 3.5, it'll just blow up, just like. Okay, so if you might remember that both on the page on the paper there, and also at lab when I was actually typing there. At one point I said what if I just type some random word here at the thing, and I type some word like spinach. I don't know what I wrote because I always just whatever. So I just type spinach there, and press enter, and then what did MATLAB say? It said spinach is undefined. That's not a thing. And then I defined it, and then we used it. Okay, so what we want to do is we want to write a program that does that. So if someone were to type good underscore number and then plug in 3.5, it won't return true. It won't return false. Rather, it's going to say, it's going to blow up. It's going to say, no, that's not something that we do. That's undefined. Okay. So the convention when you're writing MATLAB functions is that whatever the name of the function is, its contents have to be in a file with that function name and then .m. So because we want to define a MATLAB function named good underscore number, that's what we want. That means that the contents of that function have to be in a file named good underscore number .m. Okay, so if we wanted to write a function named banana, it'd be in banana.m. Okay, so here's the contents of good of the file good underscore number .m. So now I'm gonna write some stuff that is MATLAB code, and remember that some words are like special to MATLAB. You're not allowed to use them except for their intended purpose. So like it's fine for you to make a variable named spinach or to name something called spinach, but so like at the command line you could type like spinach equal 8. That'd be fine. But some words are for special purposes only, and an example of such a word is function. Right? So you can't make a function named function, and you can't make a variable named function. Okay, so such words are called keywords or reserved words and things like that. So now I'm going to write MATLAB, and every time I write a word that MATLAB construes as special, I'm going to write it in color, in red, and the rest of it I'm just going to write in pencil. Okay, so the very first word is function, and I'm writing it in red because it's special. And the word, writing that word there tells MATLAB, okay, I'm defining a function in this file. And the way it works is now you write the function's signature, there's just one output of this function, so we need to give a name to that output. What do you want to name it? How about B? Doesn't matter. All right, B. And then it's just got the one there, so I write B. And then you write equal. Okay, and now you write the function's name. Okay. So good underscore number. And then you've got some open and closed parentheses, like this. And then in these open and closed parentheses, you need to write the names of the inputs, however many there are. If there were 8 inputs, it would be the first one, comma, the second one, comma, all the way down. But how many inputs does this function have? Just one. So we just need to write one thing in there. What do you want to write? X? All right. Doesn't matter. Well, it does matter a little bit. Right? For example, you wouldn't want to name it. You could name that input in principle almost any word that you care to use. But you can't use something like function. You can't call it function. And it would I'm not even sure what would happen. I don't think it would work if you called it good underscore number. That would be super confusing. And it's possible, but very bad style, to call it B. that would don't do that. Okay, so now what we want to do is we want to write something. So I'm going to leave myself some vertical space right here. So because I'm going to write in there in just a moment, but I'm leaving it for the moment. And now I want to write the definition of this function. Okay, so how can we do it? What do you think? Okay, I'm going to come back to that. So that's a good place to start, but I'm going to come back to that. Does anybody else have a different idea? Anybody else have a different idea? So, like, for example, like the way I described it in English here. I started out by saying if thus and such. Okay, how do you do that in MATLAB? Yeah, MATLAB has an if in it. So if, besides function being special, if is special too. So now I'm gonna do this like this. But remember, I've got some vertical space there. I'm going to come back and write a much better way to write this function. But right now I'm going to do it this way. Okay, so the first condition is that if the input is 23. Okay, so you can write that as we named the input x. So if x, and what I want to say is equivalent, but I'm going to write if that, and then 23. And for those of you paying close attention, yes, there's some kind of problem here, but I'm not talking about it yet. So if x is 23, then we want to do something. Another possibility is that maybe it could be 70. So one way to do it is with those vertical bars that we talked about last time. But another way is to do it like this. You could say else if. So that's all one word, else if. And then you can write the next condition that you want there. The next condition you want to check. So you could write something like, x equal 70, like that. Okay. And then, so that kind of covers that first line. And then we wrote otherwise. So how do you pronounce otherwise in MATLAB? As else. So now these two, if has this expression that evaluates to a logical, which means false or true. Else if also has its thing. You can have 0 or more else ifs. Like syntactically, it's not required to have an else if. But here I've written an example where there's 1. There could be 101. So I could say, if this, else if, else if, else if, else if, else if, all the way down the line. Okay, but else is unconditional. It's not else and then you check something. If you're checking something, then it needs to be else if. Else is unconditional. So now so I'm going to pause there and then say, well, if we're in here, that means that this condition was true. So if we're in there, then that means that we know, according to the description, that the output should be true. So that means that we're in here. We need to define what B is. So what do we need to write? B equal true. And then after you write that, you put a semicolon. Okay, so that's it's not quite right yet. There's still problems. But you know what we're saying is that, well, if the input is 23, B is true. The output is true. What about for this one? Again, B should be true. Okay, and then this else means otherwise. So what are we supposed to do here? Okay, so in that case, B is false. Okay, now let's there's a bunch of errors in this code here. So who would care to say one of the errors? Yeah? Very good. So so I take it to mean you're pointing at that. Okay, good. So remember that in math, equal, the symbol equal, means different things depending on the context. So when you're reading math stuff and it says something like let x equal 4, that means that from now on when I say x, you are to interpret that as meaning 4. So that kind of thing is called assignment. You're assigning the name x to have the value 4. Whereas in different contexts, you might say if x equal 4. In that case, when you're reading math, it doesn't mean that you should make an assignment. Rather, it's a check for equivalence. So here, we're checking for equivalence, which means, so that's what we want to do. And the way that you say that in MATLAB is with 2 equals. So now that's right. Similarly, same problem there. Okay, good. So that's better. There's still problems. So, like, I'll write something down and tell you, like, you know, some of y'all might go on to be teachers of, you know, maybe you go to graduate school, be a TA or what have you. So here's one of the things that when I'm grading, you know, and I kind of learned this, like, you know, when I first started, because I didn't really look at other people's work much until I had to, you know. So when people write this on their math stuff, you know, someone will write like sine of pi over 4. They'll write that, and just like that. Now, just looking at it right now, I'm like almost in a panic and a sweat. Like, oh, I can't even stand looking at that. What's you know, does anyone care to speculate what's bothering me? Yeah, the closing parentheses, right? It makes me. I'm gonna have to do it, otherwise I'm gonna get ill. Okay, so okay, better. I don't like it that they're in different colors, but I just make it red so that you remember that it was missing. So in the same exact kind of way, there is currently not a literal closing parentheses missing, but a figurative one. Something is missing. What's missing? Ends, right? So in MATLAB, for example, this is a syntactic construction if. You're saying if that, do this, else if that, do this, otherwise unconditionally do this. And now we have to say that, and we are now finished with the if syntax. How do you say it? End. So that that thing right there is like, you could kind of think of it like someone had left off that parentheses there. Okay, so MATLAB construes that one as being a syntax error. So if you had left off that if and you said do it MATLAB, MATLAB would say no, I will not. What else is missing? Now the function also needs an end. Okay, so this here, like so. Now, strictly speaking, where MATLAB is concerned, for reasons I don't understand entirely, it doesn't consider that one to be a missing that one to be a syntax error. Like it's okay for, it's not okay for that one to be missing, but it's okay for that one to be missing. In our class, it is not okay for either one of them to be missing, because I've got to read it. So you have to put them even that one. Now notice that these line up vertically. Okay, so that's an element of good style. So one thing you could do is you could like mash all of this stuff to the leftmost position so that it's like all lined up, but that it's hard to understand what it is that the code is doing when you do that. So as a result, this nice style where you can see that everything in there, everything that's indented that much over must be part of the function, like it's contained inside of it. It's in it. And similarly, everything that I'm covering up is in there. Okay, so this style of indenting to specify what's inside of what, that's part of good style. Now, finally, if you were to evaluate this function as written in MATLAB, it would confirm this. It would say, well, it would say logical 0 instead of F, right? It would do this, and at the present time, as it's written, how would MATLAB respond to that?
False.
It would say false. But in fact, what we want it to do is like blow up, right? We want it to say like no. So the way you do that, this is one of the new things we're learning today. This thing we're about to write is how you encode things like domain into a function. Okay, and this new thing that we're learning is called assert. So assert. And it's a function. It accepts 3 arguments. So we'll focus on the first argument. So the first argument is the thing that needs to be true. And if this thing is not true, I will blow up here and now, and we will go no further. So what needs to be true about the input? It has to be natural. Now, so assert is a built-in function. Like, you don't have to do it. It's already there. But MATLAB does not have a function that checks for whether or not something is natural. But what? But that's one of the things you got to write. Right? What's its name? Is in. So what do we need to write right here? If is in x, like so. So that's something you have to write. So this couldn't possibly work until you do that. When this is true, if is in x is true, then it just continues. If it's false, then it's time to blow up. So now there's 2 arguments, okay, one and then another. So the first argument is basically you want to tell the machine what went wrong, but this is not something that like a human would normally read. This is like you're telling the machine what went wrong. The next argument is you're telling any humans that might be watching what went wrong. Okay, so then like when I typed whatever it was that I typed at the console that wasn't defined, avocado, enter, and then MATLAB says, I don't know what that is. That's the human bit that you saw. Okay, so we're going to write 2 things. So the convention here for the machine part is you write something called a character string, and those are the things I was calling words, like when I wrote kitty. So that's a single tick. A single quote instead of a double quote. So you write a single quote there. Then you write the function's name. So good underscore number, like so. And then a colon. And now you write some kind of thing that basically, which says like in what way something was violated. So in the end, this is like a domain violation. So I'm going to write domain. Now this stuff I'm writing here is arbitrary, except for, well, let me say it like this. This word right here that I wrote here, that's arbitrary. Like you could write banana there, that'd be fine. But then it wouldn't be very helpful. Okay, so then now that's what we're telling the machine something went wrong. So that's another single quote. So now we want to write something that the human might look at. Okay, so then what would be something good to say to the human? Domain error. Okay, that's good, but maybe we can be a little more specific. Yeah. How about we say something like the input must be natural? That would be useful. So input must be natural. And so you're just going to have to imagine that I can continue writing, So I'm going to go to this next line and write natural like this. Period, blah. Okay, so now what will happen if at the console you type good underscore number, open parentheses, 3.5, close parentheses, enter. Now what will happen is that it'll blow up, and this will be printed to the console in red. Input must be natural. Good. Any question about this? All right. Finally, so part of the way your programs are graded is that there's like two aspects, and I've mentioned this before. One of the aspects is that your program is kind of considered to be just a black box. So it's just some kind of thing. I have no idea what's in it. I put some inputs into it, and I check what comes out. And I do this for thousands and thousands of inputs. And it's all done very rapidly. Okay, so I wrote a program that takes your program, runs your program with thousands and thousands of inputs, and just checks whether or not the output is correct. Okay, this function as written, understand that it's not really just outputs; it's actually behavior. Because I'm gonna besides legitimate inputs like plugging in 8 and 23, which are legitimate because they're in the domain. I also plug in all kinds of stuff that is just completely nonsense and illegitimate. Just all kinds of garbage into your function to make sure that it responds in the right way. So this function as written will have the correct behavior. Nevertheless, if I had asked you to write this function and you had written it this way, besides the automatic tests, I also look at all your programs, and you would get a response that says that this is bad style, and you'd have to fix it. So the problem with this is that this kind of function is logical valued, which means that its output is false or true. As a result, this is bad style for a logical valued function because there's a much better and more concise way to say it. And it was what he had begun saying. But I wanted to go down this path. So a much better way to write this would be the following. Function b equal good underscore number of x. Then you write exactly the same assert thing, copy paste or whatever. But I'm just going to write that. Understand that to mean that I copy paste. It's there. So a better way to write this is the following. is to say that b is assigned the value. So now, the test for equivalence, it's written as equal equal, but actually it's a function. That's what it actually is. And its first argument is the thing that you write on the left. And its second argument is the thing that you write on the right. So equivalence is actually a function call. That's what it really is. And similarly, so what I mean to say is that test for equivalence is a function call, and its range is the logical values, false and true. Similarly, we talked about and, conjunction, and we also talked about or, disjunction, in lab. And is also a function that takes two arguments and whose range is logical values. So we can write this very concisely as the following. We could say if x equivalent 23. Okay, that's one possibility for saying yes, right? Another possibility for saying yes is 70. So x equivalent 70. Okay, and the way we want to combine these two things is with what? With or. Now, how do you write or to MATLAB? Yeah, two vertical bars, like this. On most keyboards, that's shift and then the key immediately above enter. Okay, and then we need to write a semicolon. Okay, now end, like this. Beautiful. When you get used to looking at this, this is a far more comprehensible kind of thing than that. Okay, now for that reason, you know, some of y'all, you know, blazed a trail ahead and you know, did some of the is in and whatever functions, and you wrote them like this. And that's fine in the sense that it works. But very soon you're going to get a style violation that says, nah, come on, you gotta do it like this. Yes?
Why didn't you have to write?
I'm sorry?
How come you didn't have to write in twice?
I'm sorry, where?
The function that you just wrote.
This?
Because in the one before you wrote n twice.
Because this end corresponds to that if.
Oh, okay.
So there, you can see that because they're vertically aligned.
All right.
Other questions? Have a wonderful Thursday.